Hey guys, let's talk about exponential functions and logarithmic functions. And you should be familiar with an exponential function. It's just you start with an amount, and then each interval you multiply by a proportion. So we'll use 2 here. So 1, 2, 4, 8, 16, 32. And what I'm getting at here is that each step you multiply by the same rate. You multiply by 2. But what's changing is the amount present. So what that implies is that the rate of change of an exponential function is proportional to the amount present. So you could say that the derivative, and we'll use a to the x as a generic exponential function, the derivative of an exponential function equals the function times a constant rate of proportionality is what they call it, just times a constant. So we'll put that in the corner, and we'll use the limit definition of a derivative, and we'll see if we get the same thing, and we should. So then the limit as h approaches 0 of a to the x plus h minus a to the x over h. Now, using the properties of exponents, we can change a to the x plus h to a to the x times a to the h. So let's do that. Limit as h approaches 0 of a to the x times a to the h minus a to the x over h. And with the numerator, we can factor out an a to the x term. And since the limit's with respect to h, we can actually factor it out of the limit entirely. So we could say that that equals a to the x times the limit as h approaches 0 of a to the h minus 1 over h. So that's our derivative. Our derivative of a to the x equals a to the x times the limit as h approaches 0 of a to the h minus 1 over h, which will just be some constant value. So then, if you wanted a function that was its own derivative, you'd have to make a number such that the limit of that number to the h minus 1 over h as h approaches 0 equals 1. And that's how e is defined. So you'd have the derivative of e to the x equals e to the x times, and e is defined so that this equals 1, so e to the x times 1. And that's why e is its own derivative. And hopefully that gives you some understanding as to why the derivatives of exponential functions are the way they are. So now let's look at the inverse of exponential functions. Let's look at logarithmic functions. So I'll get rid of all this. Now with you'd have a logarithmic function log of x, log base b of x, and that would just be the inverse. With the example we had before, you had 1, 2, 4, 8, etc. You would enter those logarithmic function, and you would get 0, 1, 2, 3. So let's just find the derivative of it using the limit definition like we did before. So the limit as h approaches 0 of log base b of x plus h minus log base b of x over h. And the first thing we did with the exponential function is first thing we'll do here. We'll use a property of logarithms to move around the numerator a little bit. So we'll change that to the limit as h approaches 0 of log of x plus h over x. Because when you subtract two logs, you can condense them to have one be the division of the other. So, and then that is still over h. So now what we'll do is, why don't we move the h out front? Instead of dividing by h, let's multiply by 1 over h. And now we'll use another property of logarithms. We'll write it as the limit as h approaches 0 of 1 over h, and then we'll multiply this by h over x. And what we'll do is we'll raise the inside term of the logarithm to x over h. So log of x plus h over x to the x over h. So what we'll do next is these two h's cancel out. So we just have 1 over x here. And once again, just like a to the x, 1 over x, the limit's with respect to h, so we can just pull that out front. So now we have 1 over x times the limit as h approaches 0 of log of x plus h over x to the x over h. Well, let's simplify this fraction. Let's just break it apart to x over x plus h over x. So limit as h approaches 0 of log of x over x, so log of 1, plus h over x. And then that is raised to the x over h power, and that's still inside the logarithm. So then what we get is that the derivative of a logarithmic function is equal to 1 over x times another constant. So there are a few similarities we're seeing. 1 over x, and the limit as h approaches 0 of 1 plus h over x to the x over h is actually e. So you can write that as the derivative of log base b of x equals 1 over x times log base b of e.